Welcome to The Explainer. Today, we're going to pull back the curtain on the simple, foundational rules that literally power our entire world. We're talking about the direct current circuit. You know, the invisible force behind pretty much all of our technology, so let's just dive right in.
I mean, think about it. It feels like magic, doesn't it? You walk into a room, you flick a little plastic switch, and poof, the whole room fills with light. But it's not magic, it's physics, and it's actually way more straightforward than you might think.
You see, that connection is the key. When you flip that switch, all you're really doing is completing a pathway. You're closing a loop that lets electricity travel from its source, go do some work, like lighting up a bulb, and then travel all the way back again. And this special pathway, well, it has a name.
It's called an electric circuit. Now, the official definition sounds a bit textbooky, right? An interconnection of electrical elements. But all it really means is it's a complete round-trip path for electricity to travel. And to really get what's happening on this path, we've got to meet the key players that make the journey happen.
So let's think of our circuit like a little story. And in this story, there are three main characters: voltage, current, and resistance, or V, I, and R. If you can understand how these three work together, you've basically cracked the code to all basic electronics. Seriously.
And to make this super easy to picture, we're going to use a really simple analogy. Just imagine that our electric circuit is nothing more than a system of water pipes. Trust me, this little mental model is going to make everything just click.
Okay, first up is character number one, voltage. Let's call it the push. In our water pipe system, voltage is basically the water pressure. It's the force that's pushing the water and getting it to move in the first place. It's simple, right? No pressure, no flow.
Next up, we've got current, or the flow. If voltage is the push, current is the actual amount of water that's flowing through the pipe. It's the stuff that's actually moving and getting the work done. The more water flowing, the more power you've got.
And finally, our third character is resistance, the obstacle. In our pipe system, this is anything that gets in the way of the flow. You know, maybe the pipe gets a little narrower, or there's some gunk clogging it up. It's anything that makes it harder for that water to get through. So, we have our three characters: the push, the flow, and the obstacle. So, how do they get along? How do they interact? Well, it turns out they are all governed by one beautiful, incredibly simple rule.
This right here is Ohm's law. It simply states that voltage equals current times resistance. That's it. Think of it as this perfect little seesaw of balance. It's the elegant rule that tells us our three characters are always connected in a totally predictable way.
So what does that math actually mean for us? Well, it's pretty intuitive. If you want more flow, more current, you've got to either push harder with more voltage, or you've got to make the path easier by lowering the resistance. And if you want less flow, just add more obstacles. The key thing is you can't touch one without affecting the others. They're always in balance.
Okay, so a single light bulb in a circuit is simple enough, but things get way more interesting when we start adding more stuff, say, more light bulbs. There's a plot twist, because it turns out there are two basic ways to wire them up, and your choice, well, it changes absolutely everything.
First, we've got the series circuit. The best way to think of this is like a single-lane country road. All the electricity has to flow through the first bulb, then out of it and into the second bulb, and so on, all in one single file line. And here's the catch. If one of those bulbs burns out, the road is blocked, the whole path is broken, and everything goes dark. You know those old-school Christmas lights? Yep, that's a series circuit for you.
So what's the other option? It's a parallel circuit. Now, instead of that single-lane road, I want you to picture a big highway with lots of lanes. The electricity leaves the source, and then it splits up, with some of it going down each lane at the same time. Each light bulb gets its very own lane. So what happens if one bulb burns out? Well, its lane is closed, sure, but all the other lanes, they just keep on flowing.
All right, so let's put these two head-to-head. You can see the differences right here. In series, the current is the same for everything, but the voltage gets split up. In parallel, it's the exact opposite. The voltage is the same for everything, but the current gets split up. But the real game changer, the one that matters most in our daily lives, is that failure row. One break stops the whole show in a series circuit. In parallel, not a problem.
Okay, I know this might all seem a little theoretical. Series, parallel, why should you care, right? Well, it turns out this one choice, series versus parallel, has a massive, and I mean massive, impact on how you live your life every single day. Let's bring this all home.
So here it is, the big reveal. Why is your house wired in parallel?
Well, it's for 3 really good reasons. First, reliability. When your toaster dies, you don't want your fridge to die with it. Second, consistency. Every single outlet in your house gets the same full-strength voltage. And third, control. You can turn on one lamp without having to turn on every single thing in your house.
And that's really the bottom line. This one simple design choice, choosing parallel over series wiring, is the reason our homes actually work. It's why a broken toaster is just a minor inconvenience and not something that plunges your entire house into darkness. It's a perfect example of these basic rules shaping our entire world.
When you think about it, from the tiny little circuits buzzing away inside your phone to the enormous power grid that runs our cities, it all comes back to these same simple rules. It's all about the push, the flow, the obstacle, and how we choose to connect the path. Once you see it, you start seeing it everywhere. So what else do you think it can explain? Thanks for joining us for The Explainer.